Welcome back. In this class, we will see one important problem for your external point of view. The problem is they will give an inverter and they will ask us to find out the on resistance from VDD to VSS. That means from plus 5 volts to ground. Is it okay? Now, first of all, you should look out which type of inverter it is, whether it is an NMOS inverter or whether it is a CMOS inverter. Can anybody try to tell by observing this figure for a while? Yeah, absolutely. Which type of inverter it is? CMOS inverter. I hope that are you clear. It is a CMOS inverter. And the question is, we have to calculate on resistance between VDD to VSS. This is the question, guys. Okay, since it is a CMOS inverter, we are having a pull-up device as P channel and pull-down device as N channel. Now you can observe this arrow mark. For a P channel, the arrow mark is coming from the gate, and for an NMOS, the arrow mark is moving towards the gate. Is it clear? Now, first of all, we will look out this one pull up and later we will look out pull down. Now, we know very well how to determine the resistance. R pull up is equals to Z into RS. How to find out Z? Z is equals to L upon W, where L is 2, W is 2. Therefore, it becomes 2 by 2. 2 gets cancelled, which is equals to 1. Then for PMOS, what is the sheet resistance? Let us consider 5 micrometer technology. The sheet resistance is what? 2.5 into 10 to the power of 4. That means 25 kilo ohms. Therefore, I can conclude that RPU is equals to 25 kilo ohm. Similarly, if you observe that for NMOS transistor, R pull down is equals to Z into RS. What is Z? That is 4 divided by 1. Why? Because length is 4, width is W, width is 1. Then Z is equals to 4 is to 1, which is equals to what? 4. Therefore, we can conclude that R pull down is equals to 4 into sheet resistance. What is the sheet resistance for N channel? If it is a 5 micrometer technology, absolutely 10 to the power of 4. That means 10 to the power of 4 means 10 kilo. I hope that are you clear. Therefore, 4 into 10 kilo ohms, which is equals to what? 40 kilo ohms. Therefore, finally, R pull up is equals to 25 kilo ohm. R pull down is equals to 40 kilo ohm. Now, let us consider, they said to find out the on resistance between VDD to VSS. Okay. Now, if you observe that if Vin is equals to, that means if this supply is equals to 0, PMOS will turns on, NMOS will turns off. Therefore, we are having only a pull-up resistance. If the Vin is equals to 1, then NMOS will turns on, PMOS will turns off. At that time we are having only pull down resistance. We do not have any chance to determine the on resistance between VDD to VSS. Why? Because only one of the transistor is going to be turns on. Therefore, it is very clear for us there is no on resistance between VDD to VSS since CMOS inverter, or you may write CMOS logic, CMOS doesn't applicable to a ratio rule. This is an important point you have to write. There is no on resistance between VDD to VSS. Is it okay? This is an answer for the question. Once again, I am telling that if the arrow is coming from the gate, it is a P. If the arrow is moving towards the gate, it is N. Otherwise, you know very well, very simply, it is a fourth terminal, don't forget. That is a substrate. Otherwise, very simply, they won't provide this one and they will have only a bubble PMOS and NMOS. Is it clear, all of you? Thank you very much. Have a nice day. If you are having any query, please ask.